Hello everybody, welcome into another lesson. So today we are going to talk about introduction to series. Now in the last lesson we talked about sequences, which were simply a list of numbers or a set of numbers. Well, a series is the sum of the members of a sequence. So you take all the members of a sequence and you add them together. That's what a series is. So here you have 1 plus 5 plus 9 plus 13 plus 17. I don't know why I have the extra plus there. But anyway, what you have to do initially is treat this like a list of numbers instead of a sum of numbers. So what you have to do is find yourself what the formula for the sequence would be. In this case, it turned into a sub n equals 4n minus 3. Now, when it comes to adding these together as a series, what you use is called the Greek letter sigma. That means a sum. So this is the Greek letter sigma. Now, that I equals 1 on the lower side, that is the first value you put in. That is the very first value, and then n is your upper limit of summation, which means how many are you going to sum up. And then your a sub n is that is going to be your formula for your sequence. That goes into your series. So in this case, you would have the sum from I equals 1, your initial value of what you're putting in to the function, to 5, which is your upper limit of summation, since we're adding 5 terms together. And then you would have 4i minus 3. So this is the only exception to the rule of using the letter I. When they say I, they don't mean the imaginary number. They mean the value, the initial value, or whatever value you're putting into the n. So we're going to do the first few exercises here just simply converting these into summation notation, and then we'll do some summations. So let's go ahead here and do some more examples. Alright, let's see here. So we have 4 plus 8 plus 12 plus 16 plus 20. So, alright, so 4 plus 8 plus 12 plus 16 plus 20. So we have 5 terms again, right? Well, it looks like each term increases by 4 from the last one. So let's find a formula for if this were a sequence. And literally it's 4 times whatever number of the sequence you're on. So 4 times 1 is 4, 4 times 2 is 8, 4 times 5 is 20, etc., etc. So a sub n would equal 4n. Now, we need to find summation notation for this. So get out your Greek letter sigma. There's your sigma. You're going to start with I equals 1. So that is where it starts at the first number, that I equals 1. And then there are 5 numbers, so 5 will be your upper limit of summation. And then this will be of 4i. You would write the sum from 1 to 5 of 4i, and then you just put in the values and add them together. So that's how you would convert that to summation notation. Alright. So those past two, because they only stopped at 5 numbers that you were adding together, those are what was called a finite sequence. They're finite sequences, or finite series, excuse me, meaning that we'll actually come to a numerical value. If they have a numerical value, then the series converges, which means it'll converge upon an actual numerical answer. Now in a minute we're going to talk about an infinite series in which it diverges, which means it has no finite answer. It just keeps going to infinity. So let's say here we have negative 3 plus 3 plus 9 plus 15 plus 21 plus ... So unlike before, we just had 5 terms. This time it keeps on going and going infinitely. There is still a way to express this. Well, first, let's figure out what the formula for the sequence would be. So we start with the number negative 3, right? That is our first value. Plus, it increases by 6. So it's going to be 6 times the number you're on minus 1. So if I put in 1 for n, I would get 0 here, just get negative 3. If I put in 2, I would get 6 times 2 minus 1, which is just 6, plus that negative 3 is positive 3. If I put in 3, I would get 6 times 3 minus 1, which is 6 times 2, that's 12. Plus that negative 3 gives me 9. So this formula fits. So let's simplify this formula a little bit. Do the distribution here. So negative 3 plus 6n minus 6. So you can really say a sub n equals 6n minus 9. That would really be the simplified formula for the sequence. A sub n equals 6n minus 9. Now, we need to write this in summation notation for the sum of all these numbers. Well, it's still going to be the sigma, the I equals 1, meaning that's your first number below that. But this is what's called an infinite series because it keeps going. It is an infinite series, and this series is going to diverge because it doesn't have an answer. Now, believe it or not, some infinite series will actually have a finite answer. When we get into infinite geometric series, you can have finite answers, but that's a few lessons from now. For today's purposes, all infinite series are going to diverge. They're not going to have a finite answer. It'll go to infinity. So, anyway, you start with your first number, and since it goes to infinity, you'll put the infinity symbol at your upper limit of summation. And then you'll just, for the formula, you'll just put in that 6i minus 9. That would be the formula here for the sum. So that's what all this would turn into. Alright, let's see. We have 1 minus 2 plus 3 minus 4 plus 5. Minus ... Okay. So 1 minus 2 plus 3 minus 4 plus 5 minus ... So this is another infinite series because it keeps going. So let's figure out a formula for the sequence part of this. Well, it's alternating positive and negative, right? Starts positive, then negative, positive, negative, positive, then back to negative. And it would keep doing that infinitely. So you're going to definitely have a negative 1. And this is going to be, you could either say to the n plus 1 or n minus 1 power. I'll say to the n plus 1 power. Because your first term is positive, and if I put in 1 for n, I would get negative 1 to the second, which would make this positive 1. To get my second term, if I put in 2, I would get negative 1 to the third, which would give me a negative term. Now, this also goes up by a difference of 1. I have a difference of 1. So it's going to be the number of the term I'm on. It will literally be the number of the term I'm on. So that's the formula. So if I put in 1 for n here, I would end up having positive 1. If I put in 2 for n, I would end up having negative 2. Put in 3, I would have positive 3, and so on. So this is my formula for the sequence part of it. A sub n equals negative 1 to the n plus 1 times n. Now I need to write this as a sum. So again, break out your Greek letter sigma. The I will start at 1. That's where the summation starts. But this is an infinite series, so infinity will be your upper limit of summation. And then you'll just put in your A sub n formula here. This would end up being the negative 1 to the I plus 1 times I. So again, you just start with the number 1 since you're starting with the first number, and then your upper limit of summation is how many terms you have in the series. And then your formula that you had for the sequence, you'll put that in there for the sum. Alright, let's see. Negative 7 minus 8 minus 9 minus 10 minus 11. Alright. So we have negative 7 minus 8 minus 10 minus 9 rather minus 10 minus 11. So let's work on finding a formula for the sequence part of this. So we start with negative 7, right? And then we actually decrease by 1 every term. So this would be plus negative 1 times n minus 1. So if I put in 1 for n, I would get 0 here. That would just give me negative 7. If I put in 2 for n, I would literally then end up getting 1 times negative 1 is, well, negative 1 plus negative 7 is negative 8. Put in 3, I would get negative 1 times 2, which would give me negative 7 minus 2, give me negative 9. So this formula holds. Now let's simplify this a bit. So negative 7 minus n plus 1. So the simplified formula is going to end up being negative n minus 6. That would be my simplified formula for this, would be negative n minus 6. Now I need to write this in summation notation to get the sum of this series. So sigma, of course, the I is going to equal 1 for where the number starts for your first number, but this time it's a finite series. It only has 5 numbers, so you'll put 5 for your upper limit of summation. And then, of course, the final step is you'll put in your formula for the sequence, which would be negative I minus 6. That's how you would express this sum. I think using sigma is actually pretty cool. I like using it. It's a lot of fun. Alright, let's see. We have 5/6 plus 6/7 plus 7/8 plus 8/9 plus ... So we actually have another infinite series rather. Well, first let's find a formula for the sequence side of this. So we start with a number 5 in the numerator, right? And it increases by 1. So this would actually be 5 times the number you're on, 5 times the number you're on there. So, well, no, that wouldn't be right. That'd be 0. So you start with 5, and then you're going to increase by 1. So you end up getting the formula, of course, where you start 5, plus then you have the difference of 1 between each number, then just n minus 1. You put in the various numbers, put in 1 here, you'll just get 5. Put in 2, you get 2 minus 1, you would get 6. Put in 3, you get 5 plus 2, which is 7. So this works. Now we still have to figure out the denominator. This time we start at 6 in the denominator, but there's a difference of 1 between each of the numbers, so this would still be 6 plus n minus 1. Then if you put in 1, you would get 6. Put in 2, you would end up getting 7. Put in 3, you get 8. So this holds. So why don't we simplify the formula a bit? This would turn into 5 plus n minus 1 over 6 plus n minus 1, which means our sequence formula is then going to end up being n plus 4 over n plus 5. So we got our sequence formula. Now last but not least, we need to convert these to a sum notation, summation notation. So get your sigma. Again, I equals 1. We're going to start there for the first number. Now this series continues forever, so infinity will be your upper limit of summation. And then last but not least, you put in your formula for what your sequence was. So this would be the sum from 1 to infinity of actually, let's use I in this. I plus 1, or I plus 4 rather, over I plus 5. So this would be the sum from 1 to infinity of I plus 4 over I plus 5. That's how you would express the sum. All right, let's see. We have 1 plus 0.1 plus 0.01 plus 0.001. All right, so 1 plus 0.1 plus 0.01 plus 0.001. We need to find, of course, a formula if this were a sequence instead of a series. So notice these are in powers of 10, right? Because the first one you could say is 10 to the 0 power. Second one is 10 to the negative first power. That would be 1/10. The third number is going to be 10 to the negative second power, which would end up being, of course, 1/100th. And then you have 1/1000th. Well, it just so happens you're going to have 10 to the n minus 1 power. Because if I put in 1 for 10, if I put in 1 for n, I'll get 10 to the 0, which is 1. If I put in 2, I'll end up getting... Actually, this should end up being negative, excuse me. This should be negative n plus 1, excuse me. Well, still, if I put in 1, I'll end up getting 10 to the 0. If I put in 2 for n, that'd be 10 to the negative 2 plus 1, which would be 10 to the negative 1, gives me 1/10. Negative 3 plus 1, that'd give me 10 to the negative second, which would give me 1/100th, and so on. So the formula for this is going to be a sub n equals 10 to the negative n plus 1. Now we need to write this in summation notation. Well, get your sigma. It's still I equals 1. That's where you're starting, but there's only 4 terms in this sum, so your upper limit of summation will be 4. And then last but not least, put in your formula for the sequence. That would be 10 to the negative I plus 1. That would be your summation formula. One more like this, then we're actually going to do some sums. Alright. 1 plus 4 plus 9 plus 16 plus 25. Does it continue more? Plus 36. Alright, so we have a sum with 6 terms. 1 plus 4 plus 9 plus 16 plus 25 plus 36. Alright, well, first let's find a formula for the sequence. I think this one looks a little obvious. That's just taking each value of n. So 1, if you took each of these to the second power, 1 to the second power is 1, 2 to the second power is 4, 3 to the second power is 9, so on. So you would get the formula a sub n equals n squared. Now we need to convert this to a sum, since we have a sum. So sigma with I equals 1 for the lower part. Now you have 6 terms in this series, so your upper limit of summation would be 6. And then put in your a sub n formula, but we're going to use I. It would be the sum from 1 to 6 of I squared. That would end up being your sum formula. Alright. Now, let's shift gears and go the other way a little bit. What if we were given, we have the sum from I equals 1 to 6 of 3i. We're being asked to find the sum of this series, I equals 1 to 6 of 3i. Well, what you're going to do is find each term. So, if I take a sub 1, that's going to equal 3 times 1, which would give me 3, right? If I want to find a sub 2, that'd give me 3 times 2, which is 6. A sub 3, that's 3 times 3, which is 9. A sub 4 is 3 times 4, which is 12. A sub 5, 3 times 5, that's 15. And then a sub 6, well, that's going to end up being 3 times 6, which is 18. So what you have to do, see how many terms you have in your upper limit of summation, and list those terms, and then you add them together. So this is going to turn into 3 plus 6, plus 9, plus 12, plus 15, plus 18, and we should get an answer. This is a finite series, so we should get a finite answer. So let's add all these values together. 3 plus 6 plus 9 plus 12 plus 15 plus 18 should get 63. So the sum of this series would end up, in fact, being 63. That would be the answer we get, is 63. If you take the sum from 1 to 6 of 3i, you get 63. And I got more. Alright, this time we have the sum from I equals 0, so we're starting with a 0 value to 5 as our upper limit of summation of 12i. Well, let's list all our terms. Let's take a sub 0, which would be 12 times 0, that's just simply 0, right? A sub 1, so we'll put in 1 for I, that would end up giving you 12. If you put in a sub 2, 12 times 2 is 24. A sub 3, 12 times 3 is 36. A sub 4, 12 times 4, that's 48. And then do a sub 5, well, 12 times 5 is 60. So you start with your lower index of summation, the lower limit of summation, which is 0. put that value in, and then go all the way to 5 and list your terms. Now we just take all these and add them together. So you'll take 0 plus 12 plus 24 plus 36 plus 48 plus 60, and we should get another finite answer. Alright, so 12 plus 24 plus 36 plus 48 plus 60. I should end up getting 180. So the value of this, the sum of this series would in fact be 180. Now, sometimes they'll use n instead of I in your summations. That means the same thing. They'll use n, they'll use I, they could use other variables, but usually it's either I or n. So they use them interchangeably. Now, we got the lower limit of summation being n equals 0 to the upper limit of summation, which is 4 of n squared. So once again, we're going to start by listing the terms, the 0th term all the way up to the 4th term. So a sub 0, if you take 0 squared, well, you get 0. A sub 1, 1 squared is 1. A sub 2, well, 2 squared is 4. A sub 3, well, 3 squared is 9. A sub 4, well, 4 squared is 16. And we can stop there because we only went up to 4. Now that we've listed all our terms, it's time to add them together. So 0 plus 1 plus 4 plus 9 plus 16. So let's see, 5, 14, 16 is 30. So the sum of this series should in fact be 30 once you add all these together. So doing these isn't too bad. That Greek letter sigma can look rather intimidating at first, but it's really not that bad. Alright, so we have the sum from n equals 1 to 3 of 4n to the third power. So we have the sum from n equals 1 to 3 of 4n to the third power. So we start with the first term, only go to the third term. So let's go ahead and find those three terms. So a sub 1, since we're starting on the first term, that's going to be 4 times 1 to the third power, which would just be 4 times 1, which is simply 4. Now let's find a sub 2. So that'd be 4 times 2 to the third power. Well, that's going to equal 4 times 8, which would end up being 32. And then let's do the third term, since that's the upper limit of summation. So that would equal 4 times 3 to the third power, which would equal 4 times 27, which would give you 108. Now that we found all three terms, we just need to take them and add them together. So take 4 plus 32 plus 108, which should give you 144. So the sum of this series would in fact be 144. You also may sometimes see k. They will sometimes use k. So you have the sum from the start of the summation where k equals 1 to the upper limit of summation, which is 5 of k squared minus 1. So that means we need to find 5 terms, the first 5 terms of the sequence. So a sub 1, alright, so if I put in 1 for k, I get, well, 1 squared is 1, so I'll get 1 minus 1, which would give me 0. The first term, 0. Second term now, if I take 2 to the second, I get 4, so this would be 4 minus 1, which would equal 3. If I take a to the third, a sub 3, if I take 3 to the second, that's 9 minus 1, which would give me 8. Then I find the fourth term. Well, that would be 16 minus 1, which would end up being 15. Then, of course, we got to find the fifth term because the upper limit's 5. So 5 to the second, that's 25 minus 1. Well, that'll end up giving you 24. Now to find the sum, we're just going to add all these terms together. So 0 plus 3 plus 8 plus 15 plus 24. And we should get a finite answer for this. Three plus 8 plus 15 plus 24 gives me 50. So the sum of this series should in fact be 50. That would be my sum, is 50. All right, here's a good one. So we have the sum from where n equals 2. It actually starts at 2 to the upper limit of summation of 10. So we're starting on the second term, going to the 10th term. We're going to add all those terms together of 2 over n. Well, we got to find terms 2 through 10. So to find the second term, you would put in, of course, 2 divided by 2, which would give you 1. If we want to find the third term, that's going to end up being, of course, then 2 divided by 3. Not much we can do there. If we want to find the fourth term, that would be 2 divided by 4, which we know equals 1/2. Let's find the fifth term. So that's just simply going to be 2 divided by 5. Let's find the sixth term, which would end up being 2 divided by 6, or simply 1/3. Find the seventh term. That would end up being, of course, 2/7. Can't simplify that any further. Find the eighth term. Well, that would be 2 divided by 8, which would end up, of course, being 1/4. Find your ninth term, a sub 9, that's just simply going to end up being 2/9. Then find your 10th term. Well, that would be 2 divided by 10, which would be 1/5. So now we just got to take terms 2 through 10 here, add them together. So we'll take 1 plus 2/3 plus 1/2 plus 2/5 plus 1/3 plus 2/7 plus 1/4 plus 2/9 plus 1/5. Yikes. This looks pretty horrific, doesn't it? Let's make this a denominator of 1 to kind of help us out. Well, of course we need to get common denominators. And honestly, your best bet is just going to be multiply all these together and see what the heck you're actually going to get. So 3 times 2 times 5 times 7 times 4 times 9 times... You should get a denominator of 7,560. So your first term would be 7,560 out of 7,560 plus, all right, 7,560 divided by 3, that's 2,520 that I need to multiply both the numerator and denominator by. So if I multiply the numerator by that, I would get 5,040 over 7,560. Now, let's figure out the next one. So 7,560 divided by 2. Okay, so I need to multiply numerator and denominator by 3,780. So this would give me 3,780 over 7,560 plus, we got our 2/5. All right, so I need to multiply numerator and denominator by 1,512. So if I multiply the numerator by that, I should get 3,024 over 7,560 plus, oh no, we're not done yet. We still have the 1/3. So again, what was 7,560 divided by 3? Okay, multiply numerator and denominator by 2,520. This will be over 7,560. We still got to deal with 2/7, 1/4, 2/9, and 1/5. Alright, so let's see. 7,560 divided by 7's 1,080. Multiply that by 2 for the numerator. You get 2,160 over 7,560. Plus, now you have to deal with your 1/4. 7,560 divided by 4 is 1,890. So I'll have 1,890 over 7,560. Plus, now I got to convert 2/9 into a form of 7,560. That would be 840, so if I take my numerator, multiply 2 by that, I should get 1,680. So 1,680 over 7,560. And we got that final term, that 1/5, we got to convert to a form of that. So it would become 1,512 over 7,560. That's a doozy, isn't it? So let's add all the numerators together. You'll end up getting 29,166 over 7,560. That would be your sum. Which we're going to convert that into an approximate decimal. To 2 decimal places, that's approximately 3.86. So you get the answer 29,166 over 7,560, which is approximately 3.86. That would be the sum of this series. I got just one more. And it's actually an infinite series, but it's not going to be as bad as you think. I'm going to demonstrate it. Alright, so what do we have here? We have this series where n starts at 1, where the upper limit of summation is infinity, of n over n squared minus 1 over n. So we have the summation from n equals 1 to the upper limit of infinity of n over n squared minus 1 over n. And at first you see infinity, you're probably like, well, it's going to diverge. There's no answer. Well, let's look at the formula for the sequence, right? What about that n over n squared? In the first term, can't we factor out a common n between numerator and denominator? This would become the sum from n equals 1 to infinity. This would become 1 over n if you simplify the first expression minus 1 over n, right? Well, what is 1 over n minus 1 over n? That's going to equal 0, right? So from n equals 1 to infinity of 0. So literally now this is saying I'm going to go from 1 to infinity, I'm going to add 0 infinite times. Well, 0 plus 0, even infinite times, is still 0, right? So this is actually a convergent series. It actually has a finite answer. You actually end up getting 0. So always see if you can simplify these first, because sometimes you still get a finite answer even if it's an infinite series. So that's it for this lesson. Next lesson, actually the next 2 lessons, we're going to talk specifically about arithmetic sequence and series. The next lesson will be arithmetic sequence. So I hope everyone has a great day. Take care.